Airbus has just shaken up the aviation industry by unveiling that the A350 will be powered by the newly upgraded Trent XWB-84 engine. This isn't just an engine upgrade, it's a transformative step towards greater efficiency and sustainability. So, why is this new engine causing such a stir, and how will it impact the future of aviation? Let's explore the groundbreaking technology behind this development and its potential to reshape the skies. To understand the significance of this upgrade, we need to look at the strategic vision driving Rolls-Royce's decision. CEO Tuen Ergen Bilgic has announced a colossal investment, over $1 billion, into the Trent XWB-84 and other product lines, aiming to compete directly with GE Aerospace's GEnx-1B engine. This investment isn't just about staying in the game, it's about dominating it. Rolls-Royce plans to quadruple its annual operating profits to $3.5 billion by 2027, increasing its operating profit margin to an unprecedented 14%. These are numbers that the company has never achieved before, signaling an ambitious push to reclaim its position at the forefront of the aviation industry. This strategic move follows the challenges the company faced, including the durability issues with the Trent 1000, which have plagued the company since 2016, and the severe impact of the COVID-19 pandemic on long-haul travel. The pandemic led to a significant decline in demand for long-haul flights, which in turn affected Rolls-Royce's revenue, as the company's engines are predominantly used in wide-body aircraft designed for such routes. The costly development of fixes for the Trent 1000's durability issues further strained the company's resources. These setbacks are exactly why the upgraded XWB-84 isn't just an answer to these challenges, it's a bold step into the future. It's designed to restore faith in Rolls-Royce's engineering prowess and set a new standard in the aviation industry. So, what makes the upgraded Trent XWB-84 so special? For starters, it's exclusively designed for the Airbus A350-900, particularly the ultra-long-range variant. This engine isn't just about power, it's about efficiency, reliability, and sustainability. The A350-900 ULR is a marvel in its own right, capable of flying non-stop on ultra-long-haul routes of up to 9,700 nautical miles or about 18,000 kilometers. This extraordinary range is made possible by the aircraft's lightweight design and, of course, the Trent XWB-84 engine, which has been a key factor in making the A350-900 one of the most efficient wide-body aircraft in the world. Rolls-Royce has completed over 100 successful test flights with the upgraded engine, and certification is expected by the end of this year, with service entry planned for 2025. The introduction of this engine will mark a significant milestone for Airbus as well. With the XWB-84, airlines will be able to operate even longer routes more economically, potentially opening up new direct connections between cities that were previously out of reach. Imagine flying from Sydney to New York non-stop, or from Singapore to Los Angeles, cutting down on travel time and increasing convenience for passengers. On such long routes, even a 1% improvement in fuel efficiency can lead to significant cost savings, making the XWB-84 not just an upgrade, but a game changer. But how exactly will this engine be upgraded? The enhanced performance variant of the XWB-84, first introduced at the Singapore Air Show in 2016, is already a step ahead in terms of fuel efficiency and emissions reduction. However, Rolls-Royce plans to push the boundaries even further with the upcoming upgrades. The new EP model will incorporate advanced technologies from the higher thrust XWB-97 engine, which is used on the A350-1000, as well as insights from the cutting-edge UltraFan program, a research initiative focused on developing the next generation of ultra-efficient jet engines. One of the most significant innovations in the EP model is the introduction of turbine discs made from a proprietary superalloy known as RR-1073. This material was originally developed for the UltraFan program and is capable of withstanding temperatures 50 Kelvin higher than previous materials. This increase in temperature tolerance translates to improved fuel consumption by up to 1%, reduced carbon emissions, and a more predictable engine lifespan. These are not just incremental improvements. They represent a significant leap forward in engine technology, ensuring that the XWB-84 will remain at the forefront of the industry for years to come. Additionally, the EP model will feature a new process for redistributing cooling air through the high-pressure turbine blades, significantly reducing operating temperatures. This not only enhances the engine's efficiency, but also its durability, particularly in harsh environments where high temperatures and abrasive materials, such as sand, can cause significant wear and tear on engine components. Rolls-Royce is also working on a new sand-resistant coating for the turbine blades, which will be particularly beneficial for airlines operating in regions with high levels of airborne particulates, such as the Middle East. Furthermore, the engine's secondary air and sealing systems between stages have been optimized, and the turbine blade clearance control system has been further refined to improve overall aerodynamic efficiency. These enhancements are all designed to make the XWB-84 not only more powerful, but also more reliable and easier to maintain. In other words, this engine isn't just efficient, it's built to last, offering airlines a significant return on their investment. Let's break down what makes the XWB-84 engine truly remarkable. With a thrust rating of 84,200 pounds, it's specifically designed to deliver optimal performance on long-haul flights. Currently, 295 Airbus A350-900 aircraft are powered by this engine, benefiting from a 15% reduction in fuel consumption compared to older models. Its innovative design includes a large fan and sophisticated cooling system, allowing it to operate efficiently even under the most demanding conditions. The XWB-84's fan diameter is larger than that of its predecessors, allowing for greater airflow and improved efficiency, which in turn reduces fuel burn and emissions. Additionally, the Trent XWB-84 is engineered to reduce noise and emissions, making it a key player in meeting stringent environmental regulations. The engine features an advanced nacelle design that reduces aerodynamic drag, further improving fuel efficiency and reducing noise. This is particularly important as global aviation faces increasing pressure to reduce its environmental impact. The XWB-84's ability to meet and exceed current environmental standards makes it a crucial asset for airlines looking to future-proof their fleets. But the XWB-84 isn't just about meeting regulations, it's about setting new benchmarks. Its innovative design and advanced materials not only enhance its performance, but also extend its service intervals, reducing the frequency of maintenance checks and lowering operating costs for airlines. This engine doesn't just power aircraft, it powers the future of sustainable aviation, offering a compelling combination of performance, efficiency, and environmental responsibility. Of course, no innovation comes without its challenges. Rolls-Royce initially planned to deliver the first XWB-84 EP engines to Singapore Airlines by the end of 2019, but this timeline has been delayed. The reasons are multifaceted, including the technical challenges posed by the Trent 1000 and the pandemic's impact on long-haul travel. However, Rolls-Royce remains confident that these setbacks are temporary. The Trent XWB-84 is not only the most efficient large aircraft engine in operation today, but is also recognized as the industry standard for reliability. The delays may have slowed its entry, but they haven't diminished its potential. The company has also been dealing with the logistical challenges of ramping up production for the new engine. The supply chain disruptions caused by the pandemic have affected the availability of certain critical components, leading to delays in manufacturing. Despite these obstacles, Rolls-Royce has been working closely with its suppliers to ensure that production schedules are back on track, and the company is optimistic about meeting its revised timeline for the engine's market entry. Furthermore, the delays have provided Rolls-Royce with an opportunity to conduct additional testing and fine-tuning of the engine, ensuring that it meets the highest standards of performance and reliability. This extra time has also allowed the company to incorporate feedback from the initial test flights, further enhancing the engine's design and functionality. In the long run, these improvements will likely pay off, as airlines increasingly look for engines that offer both high performance and long-term reliability. As we look to the future, it's clear that the new Trent XWB-84 engine is more than just an upgrade, it's a revolution in aviation technology. It represents the culmination of years of research and development aimed at creating an engine that not only meets the demands of today's market, but also anticipates the needs of tomorrow. But what do you think? Will this engine overcome the challenges it faces and lead the charge toward a more sustainable future for aviation? Share your thoughts in the comments below. And if you're as excited about the future of aviation as we are, hit that subscribe button and join us for more updates on this groundbreaking technology.